Hi, welcome to another video tutorial in which I'm going to be talking to you about character sets, and in particular ASCII and Unicode, which are the two character sets you need to know about for GCSE and A-level computer science. So just what is a character set? A character set is a collection of defined characters that a computer is able to use. ASCII and Unicode are the two character sets, as I've just mentioned, that you need to know about. And what I've got, you may have noticed on the right hand side of the screen here, is the set of printable ASCII characters. So in ASCII, and in other character sets as well, you have characters like, for example, a null character, which aren't printable because nothing appears on the screen when that character is displayed. And But what you'll need to deal with in exam questions is the set of printable ASCII characters, so the alphabet and punctuation and symbols and things like that you would actually see when your computer displays a document to you. So let's look at ASCII first of all then. ASCII stands for the American Standard Code of Information Interchange. So ASCII, American Standard Code for Information Interchange. And it's a 7-bit character set. And what that means is we've got 7 bits to represent our characters with, so we can represent with the original ASCII code, we can represent 2 to the 7 different characters. There is something called extended ASCII, and that uses 8 bits. And so therefore you can represent slightly a bigger number of characters, but you're just concerned with 7-bit ASCII, the original ASCII code, and 2 to the 7 equals 128, and that's how many characters we can represent. And you can see down on this table I've got from 33 down to 124. And the other characters are, as I've previously mentioned, what are called non-printable characters. What you'll notice here then, if we take a further closer look at this table, is that character codes are grouped and they run in sequence. And what I mean by that is that we've got all of the capital letters grouped together here from 65 for capital A down to 90 for capital Z, and they run in sequence. And what this means is that if you're given that the character code for A is 65, you could work out what all of the character codes for all of the other capital letters are, as long as you know your alphabet, and as long as you know and as long as you're able to count upwards through the alphabet, and you're able to work out, if I wanted you to work out what the character code for D was, you'd know that it was 3 letters after A, so you'd be able to go 1, 2, 3, and then find out that it's 68, because you'd be able to add 3 onto 65 to get D. And that's what you'll have to do in an exam question. That may be 1 or 2 marks for working something like that out. And it's the same with the lowercase letters. They run in sequence as well, and they're grouped together from 97 for a lowercase a up to 122 for a lowercase z. What you also need to be able to do is you need to be able to convert from a character to a character code and back again in a programming language, in your chosen programming language for your course. You should refer to my programming tutorials for help with that, and you'll be able to learn how to do that with those tutorials. Okay, so that's ASCII. Just to quickly recap, it's a 7-bit character set. That means we can represent up to 128 characters with original ASCII. We're going to be asked to calculate what the character code for, say for example, the letter P is, given that we know what the character code for the letter A is, for example. That's the sort of thing you need to be able to work out for ASCII. That's an example exam question. So that's ASCII. let's move on to looking at Unicode. And what you need to know about Unicode is that it was developed to accommodate more characters and special symbols. And Unicode allows users to use multiple different alphabets, such as, for example, the alphabet used in Chinese on computers, whereas before, using ASCII, they couldn't do that. They could only use the Latin alphabet. And Unicode also allows a greater representation of special characters. For example, currency symbols for different currencies, not just the US dollar, and which was originally included in ASCII. And in Unicode, the Unicode codes correspond to the same characters as ASCII up until code 127. So what you've got to realise is that in Unicode, capital A is going to be 65, just as in ASCII, because up until the limit of ASCII, they correspond to the same characters. Okay, so let's just quickly recap Unicode then. So Unicode was developed to accommodate more characters and special symbols. So it allows the use of different alphabets, so people in countries who don't use the Latin alphabet can use their own native alphabet. It also allows the representation of more symbols, such as symbols of different currencies. And the codes, Unicode codes, correspond to the same symbols and characters as ASCII up until code 127. And I'm saying 127 here, just note this down, because although we can represent 128 characters with ASCII, one of the character codes is going to be 0, so it's going to go 0 to 127, the actual codes. Okay, so that's just a brief overview of ASCII and Unicode. That's the knowledge that you need for GCSE and A-level. A likely question that you're going to be asked if you're doing GCSE or A-level computing about ASCII and Unicode are, what are the advantages of using Unicode over ASCII? And these 4 points here will really help you with those questions. And you're gonna need to write down, say, ask for 2 advantages. You're gonna need to write down that Unicode allows the use of other alphabets, and Unicode allows the representation of more symbols, for example. Okay, so that's the end of this tutorial video. If you've got any questions, please leave them in the comments, and I'll try and answer them as best I can. Okay, thanks for watching.